Hello my dear students, this is Raman Rana here, your mathematics teacher, Cambridge International School, Dasuga. Today we will revise the chapter sequence, chapter number 15, sequences. In revision, we will discuss simple sequences, then we will discuss arithmetic sequences, and the last, the geometric sequences. So what we understood by the sequences? So sequences, a particular pattern, arrangement. So sequences is the collection of terms. Sequences is the collection of terms, arranged in a specific order, So here the terms, and they should be in a specific order. We have, or we need, a particular rule to form a sequence. Let's take a simple example of a sequence. Like first example, if 2, next term is 4, 6, 8, 10, so on. If a sequence is having infinite terms, then it is called infinite sequence, and if it is a fixed term, then it is a finite sequence. So here, this is the first term, 2, second term, third term, and so on. One more example of a simple sequence: 1, 4, 9, 16, 25, 36, so on. So here also first term is 1, 4, 9, 16, 25, 36, 49, 64, and so on. Let's take one more example here. One is 10, 5, 5 by 2, 5 by 4, 5 by 8, and so on. So here first term is 10, second 5, third is 5 by 2, 5 by 4, and 5 by 8, so on. So we have one more, we can take one more example, like 1, 8, 27, 64, 125, and so on. So here in these simple sequence, there is a fixed rule to obtain the next term of the sequence. Like in first, if this is the first term, that is 2, if we add 2, we will get 4, again plus 2 here, 6, then plus 2, 8, 10. So here in our book, we are naming the terms like U1, U2, U3, U4, and so on. Whereas the nth term as UN. UN is the nth term of the sequence. We also name sometimes like T1, T2, T3, so on. Term 1, term 2, term 3, term 4, so on. Or sometimes also we are denoting A1, A2, A3, and AM. Nth term of the sequence here. So these are some examples. Here we have U1 is 2 here, U2 is 4. Similarly here in this sequence. First term is 1, 1 square is 1, 2 square is 4, 3 square is 9, 4 square, 5 square. Here the rule is half of 10 is 5, half of 5 is 5 by 2, half of 5 by 2 is 5 by 4, and so on. Whereas in this sequence, cube, 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, and so on. So there is a fixed rule here for in all these simple sequences, and we will discuss now the arithmetic sequences, and in some of the complex sequences we will discuss today the quadratic rule and the cubic rule. Now we have arithmetic sequence. In arithmetic sequence, the common difference between two successive terms is always same. For example, here if we have 5, 10, 15, 20, 25, so on. So here 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 5 is 5, or in another word, here u1 is equal to 5, which is the first term. As we have discussed here, u1 is the first term of the sequence, first term, u2 second term, u3, so on. So here u2 is equal to u1 plus common difference u3. Here the common difference is equal to u2, that is the 10 minus u1. So here common difference is 10 minus 5, so D is 5 here. So here we have the sequence in which all the successive terms, they have the common difference, that is 5 here. So we can take some other examples also of the arithmetic sequences, like we have 7, first term is 7, then 5, 3, 1, minus 1, and minus 3, so on. So here also first term, that u1 is 7, u2 here which is 5, that is u1 plus minus 2 here. So here that is 7 minus 2 is equal to 5. So we can find the nth term of the AP. So we have a rule. First one is term to term rule. Like if we want to find the nth term, then we will write un minus 1, this previous term, plus the common difference. So here in this case we have the common difference, that is minus 2 here. Common difference D here is u2, 5 minus 7 is equal to minus of 2 here. So in all these, in this sequence, the difference of any two successive terms, the common difference is same. So in arithmetic sequences we can find the general term or nth term, and always we have this general term always in a linear form, like a n plus b. So let's take some other examples of arithmetic sequence. Let's take some more example of arithmetic sequence. In arithmetic sequence, let's first term is 3, 7, 11, 15, so on. So here first term is 3, second term is 7, and in all here the common difference is 4. Let's take one more. If 3, 6, 9, 12, 15, 18, so on. So here one more, 7, 2, minus 3, minus 8, minus 13, so on. So let's discuss about these, why these are arithmetic sequence. Because in this sequence the common difference is same. Here the common difference is 4, in second sequence the common difference is 3, and here in the third one the common difference is minus 5. The common difference is the difference of the two successive terms. 12 minus 9 is 3, minus 8 minus of minus 3, that is minus 5 here. Now if we want to find the nth term of these AP, so here we can move ahead. Like in this case, if we want to find the 10th term of this AP, then that is equal to the formula, that is U1 plus U1 here is 3, and n minus 1, the previous, that is your n minus 1 into D. For this case it is equal to 3 plus 9 into 3, that is 27. So here the 10th term of this sequence is 30 here. If we want to go ahead for this last sequence, if you want to find the 50th term of this AP, this is equal to first term plus n minus 1, because n here is 50 minus 1 is 49, and common difference is 5. So U1 here is 7, here it is minus 24, 45. So here the 50th term, if we have to find the 50th term of this sequence, that is equal to minus of here 238. So 238 is the 50th term of this sequence. So if we want to find the 100th term, we can find easily that the first term plus 99 into D. So we can go ahead with some more examples. Here, if in the sequence we will go for the particular rule, if we have, let's take one more sequence, let it is 7, let common difference is 5, so here it is 12, 17, 22, 27, so on. So here we can write here the first term of this AP is 7, and the common difference is the U2 minus U1, the second term minus first term, that is equal to 12 minus 7 is equal to 5. So common difference is 5 here. So here we can find the general rule for, or you can see the nth term of this AP, the common difference is 5 here. So we can write here like 5n plus 2. If n is 1, then we got 7. If n is 2, we get 12. N is 3, we got 13. So we will get first term of this AP is 5 plus 2, 7. Second term, that is 10 plus 2, 12. U3, that is 17. So here, as I have discussed with you, this is in the form of A n plus b, where a and b are the constants. So after this, if we have some complex sequences, we can go ahead with the quadratic and the cubic rule. We will check the difference. Here in arithmetic sequence, the difference remains the same. Like 12 minus 7, 5, 17 minus 12, 22 minus 17, 27 minus 22. Here, the difference of the two successive terms remains the same, or we are saying the common difference remains the same. How to find the value of the constant a and b? If we have a general term of AP, un is equal to an plus b. So how to find the value of a and b? We have one more sequence. The first term, if first term, second term, third term, fourth term, and the fifth term are 4, 7, 10, 13, so on, 16. So we can make a table, the position. The first term is 4, second, third, fourth, fifth. We can compare here these terms with let the first term is equal to a plus b, second term is twice of a plus b, the third term 3a plus b, fourth term 4a plus b, and the fifth term is 5a plus b here. So here in this table, to find this nth term of the sequence, here we have a first term, second term, and so on. So here first term a plus b, 2a plus b, 3a plus b, 4a plus b, and 5a plus b. So here this is the linear equation. So here a plus b is equal to 4, because here I'm taking this as a arithmetic sequence, because the common difference in all these terms, the successive term is same. For here, the difference of these two terms is a here, the difference of these two terms is again a here, the difference of these two terms is a here, and again the difference of these two terms is a here. 5a plus b minus 4a, b cancelled, and we have the common difference same. So here a plus b is equal to 5, and twice of a plus b is equal to 7. So here we can find by solving these pair of simultaneous equations, this pair of linear equations. Here we can subtract one from another. If we subtract one equation, let this is equation number 1 and equation number 2, subtracting 2 from 1, we have minus of 3 here and b get cancelled. So here we have the value of a is equal to 3 here. So putting the value of a in any of the equation, a plus b is equal to 4. So what is the value of b? B is equal to 4 minus 3. So b is equal to 1 here. So substituting the value here in the general term, so for this sequence, the nth term of the sequence can be derived. A, in place of a we can substitute the value, that is 3, and n, and b is 1 here. So my dear students, I hope you understood the way how to find the nth term of a given sequence if the sequence is arithmetic sequence. So here we will move ahead with a plus b, first term, second term 2a plus b, third term 3a plus b, fourth term 4a plus b, and so on. And we know in such a sequence the common difference is always the same. So here we will put a plus b is equal to 4 and 2a plus b is equal to 7, and solving these pair of linear equations we are getting a and b. Substituting the value of a here, substituting the value of a, which is 3, so 3n plus 1. So if now question is, for this sequence, what is the 100th term of this AP or 150th term of this AP? So we can easily, if we want to find 150th term of this AP, we can write that A is 3, N is 150, and B is 1 here. So the answer is that is equal to 451. So the 150th term of this sequence is 451. So I hope you are understood with the linear equation of arithmetic sequence and their nth term, which is nth term is equal to an plus b. Now if for complex sequences, if the first difference here, this one is the first difference, if this difference is not same, then we will move ahead with the quadratic rule. And if the second difference is not same, then we will go for the third difference, and if third difference is same, then we will apply the quadratic rule for these complex sequences. Sequence with a quadratic rule. Sequence with the quadratic rule. Let's take one sequence whose first term is minus 6 here. Second term is minus of 8. Third term is again minus of 6. The fourth term is 6 here, and the next term is 34. So here this sequence is not now the arithmetic sequence, because here the difference vary. The difference of two successive terms is different here. So here if we go for the successive difference, here the first difference, second term, that is minus 8 minus of minus 6, which is equal to minus of 2 here. The difference minus of 6 minus of minus 8, which is 2 here, and the difference of these two terms is 12, and the difference of these last two terms is 28. So here the first difference is not equal, not same. In case if first difference is equal, then we will compare this in a plus b, 2a plus b, 3a plus b, and so on, and by putting the value we can go for the linear rule. But here now we will check for the second difference. Here it is the first difference here of the sequence, first difference. Now second difference here, second term, that is 4 here. The next here, the difference here, 2 minus a minus, that is 4. It is 10 here, the difference. And in this case here, 12, that is 16. So here, that is the second difference. Now again, we don't have the second difference same. So here we cannot apply the quadratic rule, because for the quadratic rule, nth term of the AP, nth term of the sequence, that is equal to an square plus bn plus c. But for this sequence, now we will go for the second difference, third difference. First difference is minus 2, 2, 12 and 28. Second difference is 4, 2 minus of minus 2, 12 minus 2, 10, 28 minus 12 is 16. So second difference is not same. So here the third difference, that is 10 minus 4, that is 6 here, and 16 minus, that is 6 here. So third difference is same. For this sequence, we have to apply here the cubic rule. We have to apply the cubic rule, and according to cubic rule, the nth term of the sequence is equal to an cube plus bn square plus cn plus d. So here let's take another example of the sequence where we will apply the quadratic rule. For the quadratic rule, we can take the terms of the sequence. If this is first position, second position, third position, fourth position and fifth position of the sequence, the first term we will take a plus b plus c. The position first, that is a plus b plus c. Second is, that is 4a plus 2b plus c. Third, that is 9a plus 3b plus c. And the fourth is 16a plus 4b plus c. And the last one, that is 5 is a 25a plus 5b plus c. This is the rule for the quadratic when the second difference is same, because first term, second, third, fourth, fifth, these are the terms, and if we go for their difference, this difference of these two is 3a plus b. Here this is 5a, the difference of these third and second, that is 5a plus b. Next, that is 7a, difference of fourth and third term, that is 7a plus b. And the next one, the last, fifth and fourth, the difference is 9a plus b. So here we have the first difference is not equal. If first difference is equal, then we will apply the linear rule, that is a n plus b. But here we have to go ahead for the quadratic rule, because here the second difference, now this is the first difference which is not same. Now the second difference here, the difference of here, the difference of these is 2a. Here the difference of 2a, again their difference, b cancel with b, 2a, and here again the difference is 2a. So here this is the rule for the sequence where the second difference, first difference is not equal here. If second difference is equal, 2a, 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 so we will make the table and substituting the value, we will find the nth term of the sequence. Let's take one example of the complex sequence. If first term of the sequence, that is 0, 7, 18, 33 and 52 here. Now the first difference here is 7, 7 minus 0, 18 minus 7 is 11, 33 minus 15, and here it is 19. So we have the first difference of the sequence, the first difference 7, 11, 15 and 19. Now we will go for the second difference, which is the same 4, 4 and 4. So the second difference here, the second difference, that is 4, it is 4 and 4. So here if we check the table, now to find, we know that the rule for the nth term, the quadratic rule, is an square plus bn plus c. How to find the value of these abc? Here, this is the first, we have already discussed, first, second, third, fourth, fifth. First term, second term, third term, fourth term and fifth term. So here 2a, this is equal to 2a is equal to 4. This further implies that a is equal to 2. So the value of a is 2 here. Now this value here, the difference of first and second terms, that is 3a plus b, is equal to 7. So we have 3a plus b is equal to 7. So value of a is 2. So b is equal to 7 minus 6. So b we have minus 7 minus 6, that is 1. Now we also know that a plus b plus c, this is a plus b plus c is equal to 0. So we have a plus b plus c, a plus b plus c is equal to 0. So a here is 2, b is 1 plus c is equal to 0. So this implies that the value of c here is equal to minus of 3. So now substituting the value of a, b and c, so the nth term of the sequence, that is un is equal to 2n square plus b is 1, that is n minus of 3 here. Let's check. If n is 1, so 2 plus 1 is 3, 3 minus 3 is 0 here. If n is 2, second term is 7, let's check. 2 square is 4, 4 into 2, 8, 8 plus 1, 9, 9 here, 8 plus 2, 10, 10 minus 3 is 7. So here we can find the nth term of the given sequence by using the quadratic rule. Now we will go for the cubic rule. Cubic rule for a sequence. Cubic rule if again this is the first term, second, third, fourth, fifth. Let the first term, that is here it is the position, so here A plus B plus C plus D. Second, eight A plus 4B plus 2C plus D. Third term, the rule for the third term, that is 27A plus 9B plus 3C plus D. So here fourth one, 64 4 cube, that is 64A, 4 square, that is 16B plus 4C plus D. Similarly, the fifth term is 125. 5 cube is 125A plus 25B plus 5C plus D. So here these are the respective terms, first term, second term, third term, fourth term and fifth term of the sequence. So their first difference, that is second term minus first term, that is 7A. This is difference, that is 7A plus 3B plus C. Now third and second difference, so here that is 17 minus 8, that is now difference is 19A plus 5B plus C. Now the next difference, that is 64 minus 27, that is 37A plus 7B plus C. And the last difference here, 125 minus 64, that is 1 and 61A plus 9B plus C. So this is the first difference. Now for the second difference, this is the first difference. For the second difference, we have 19 minus 7, that is 12A plus 2B. Next here, 37 minus 19A, that is 18A plus 2B. And the last difference, 61 minus 37. So here it is 24A plus 2B. So again we have second difference is different. Now we will go for the third difference. So here we have the third difference, that is third difference, that is 6A, and this is 6A. So we can by substituting the values, these specific values, we can find the values of these coefficients, or this value of A, B, C and D. The rule, cubic rule, is if nth term of the sequence is equal to an cube plus bn square plus cn plus d. Already we have discussed one example of a cubic where we have to apply the cubic rule. It is minus of 6, minus of 6, minus of 8, minus of 6. Then we have the value, it was minus 6. Then again we have 6, and we have then 34. So here we will go ahead with the first term is minus 6, second term minus 8, and here third term is minus 6, and so on. So here the first difference we have, that is minus of 2. The second difference, that is 2 here, minus of 6 plus 8, that is 2 here, here is 12, and the last difference, that is 28. Now these are the first term, second term, third term, fourth term, fifth term, and these are the first difference. Now the second difference, this is the first difference here. This is the first term, second, 5 terms. This is the first difference. So we have these first difference. Now second difference we have, that is 4. Here this is 10, and here this is 16. So we can make a table in order to make it very clear. And the next third, this is the second difference here, and the third difference, that is, this is 6, and here this is again 6. So here for this AP, so not AP, this sequence, this is a little complex sequence. First difference, that is minus 2, 2, 12, 28. The second difference, 4, 10 and 16. Now the third difference is 6 and 6. Now by comparing with the table, we can very easily find the value of A, B, C and D. So here 6a is equal to 6a here is equal to 6. So value of a here is 1. The value of a is 1. Now we have 12a plus 2b is equal to 4. I have 12a is 1 plus 2b is equal to, that is 4. So 2b is equal to 4 minus 12. 4 minus 12, that is 8, minus 8, and b is equal to minus of 4. So the value of b is equal to minus of 4. So next we can 7a plus 3b plus c is equal to minus 2. So we can substitute the value. We can substitute the value here, that 7a, a is 1, that is a is 1, b is minus 4 plus 3b plus c is equal to, so here the value of 7a plus 3b plus c is equal to minus 2. So we have 12 minus of 12 plus 7 is minus 5, and c is equal to minus 2 plus 5. So c is equal to 3 here. Now finally the value of a plus b plus c plus d is minus 6. So here we can find the value that a plus b plus c plus d is equal to minus 6 here. So a is 1, b is, the value of b is minus 4, and c is 3, plus d is equal to minus 6. So value of d is equal to minus of 6, and here it is 0. So the value of d is minus 6. So substituting the value here in this nth term, a is 1. So we have the nth term of this sequence is equal to n cube. B is minus 4, 4n square. C is 3 plus 3n plus D is, that is minus 6. So this is the nth term of this given sequence, and we have find this nth term by using the cubic rule here. So whenever we have a sequence, a complex sequence in which, here we have taken example minus 6, minus 8, minus 6, 6 and 34. So here the first difference is not same. So we have again go for the second difference, that is 4, 10, 16, and the third difference is 6 and 6. So by comparing the values from the table, first that 6a is equal to 6. So value of a is 1 here. Then the value of 12a plus 2b is equal to 4. And then 7a plus 3b plus c is equal to minus 2. And the final a plus b plus c plus d is equal to minus 1. By substituting the value, we can find the rule. So this is the rule, cubic rule, to solve these complex sequences to find the general term or the nth term of this sequence. So dear students, I hope this topic is clear to you, and you can solve all the questions from your textbook and past paper also. So all the best, stay safe, stay healthy. Thank you very much.